Good morning, everyone. 1 second while I do a. There we go. All right, good morning, everyone. Welcome to our latest webinar from the Lighting Design Lab. We are going to pause for just about 1 more minute to allow people to continue to file in. I will be back with you momentarily. All right, everyone, good morning. Welcome to Fundamentals of Networked Lighting Controls, our latest Lighting Design Lab webinar. I see that some of you have been here before, so hopefully this will be a little bit of a review. I promise I will introduce myself more fully in just a few moments, but first, before we begin, everyone is going to be muted during the class today. If you have questions, please go ahead and use either the chat feature or the questions feature that are in the control panel for GoToWebinar, and I will go ahead and keep an eye on them. There may be some cases where if I see a question that is very valuable to immediately answer, I may stop the presentation and discuss it. But more than likely, what I will do is probably go ahead and every 10 minutes or so, pause to ask for questions, and I will go ahead and address them. Go ahead and type them when they come up, and I will address them as we go through. Also, there will be a few short online polls that we will look at when we are doing the class. Please participate in those. After the class, we'll have a short survey for you to fill out. Please go ahead and do that. That's very helpful for us. And a recording of the recording of this class will be available on the LDL webpage in a day or two. Now, there are 3 handouts that you can download today from the handout section. Again, go ahead and look at the GoToWebinar taskbar, and you'll see a handout section. One of those is today's presentation, a PDF of it, of the slide deck, and 2 of them relate to the homework. You didn't realize there was going to be homework, but yes, indeed, there will be homework. So please go ahead and download those at some point during the next couple of hours that we're together. And if you have questions, lightingdesignlab@seattle.gov, or go ahead, my email will show up at the end, but it's Shaun, SHAUN.Darragh, DARRAGH, @seattle.gov. Now, we, of course, the Lighting Design Lab, are very proud to be part of Seattle City Light. We are sponsored by and have been sponsored by Seattle City Light for the last many years. Of course, we work with largely anyone in the community who needs help with respect to lighting controls, and we're expanding out into other areas of building electrification as well. Some of you may have seen that we have been doing in particular a lot of work around education with respect to heat pumps and heat pump hot water heater. In fact, we've got an educational series coming up on that a little bit later this spring. And of course, we've traditionally had 4 major areas, right? Education and training, very much like this one. We've done technology education, we've provided tools and resources to the community, and we're information aggregators. Now, as I promised, for those of you who don't know me, my name is Shaun Darragh. I am a lighting consultant. I've been a lighting designer for more than 30 years. I'm also a lighting educator. I've taught classes off and on for the Lighting Design Lab for a very long time now. and again also for the University of Washington Architecture Department since the early 2000s. But my primary background is as a private practice lighting consultant and designer of lighting control systems. So that's where I'm coming from, just so you all know. I come predominantly from the specification section. Now, why don't you guys tell me just a little bit about yourselves, if you would. I'm going to launch a poll, and you're going to see it come up on your screens. So if you would be kind enough, so that I can try to go ahead and tailor my remarks as best I can to a class like this. Do you consider yourself to be a specifier or a designer, like an architect, lighting designer, engineer, or an implementer? Somebody who is actually installing or programming these systems, you know, contractors, facility folks, trade allies. Do you sell things? Are you part of a rep agency, distributor, retail? Are you a manufacturer? Do you make this sort of stuff? Or are you perhaps utility staff or program implementer, or maybe some similar kind of institutional person? So I'm going to give you about another 10 seconds, and then we will. All right, I'm going to close the poll, and then I'm going to share the results. So about half of you or so are within the specification community. Welcome. Another group are contractors, a few salespeople, and a good showing from utility staff. So, and John says electrical contractor agent, specify rebate and customer interface. So basically all of the above. All right, that gives me a reasonable review of who is joining us this morning. So welcome everyone. Let me go back to my thing here. So we do, of course, have some learning objectives today. This is what I don't want to speculate, but I hope will be the last of the webinar series of network lighting controls. And I don't mean that to say that that's a negative thing, but I think many of us are ready to go back to in-person learning, and I really love teaching network lighting controls in person because there are a lot of things that I can do to demonstrate a lot more effectively, potentially, in person. However, all of that said, our learning objectives today, we'll talk a little bit about common control strategies, how to apply them to some specific hardware. We'll talk about how network control devices may be configured, and a little bit more, this comes to us for next week's class, the part 2 class. We'll talk about understanding the essentials of system startup, right? How do we pair devices, high trims, timeouts, things like that. If these words are all a little bit Greek to you right now, don't worry, we will talk about them all as we move forward. So with that, let us move forward right into the initial question. Why do we want to use advanced lighting controls or networked lighting controls as we frequently talk about them? There's a lot of different reasons that we would want to wind up using networked lighting controls. Now, this particular list is in a specific order because this is what's worked for me over the years to try to get my clients to understand the value of having advanced lighting controls or networked lighting controls on our projects, right? Now, the order of the list, you can vary it however you need to, however will fit your needs. As I say, this is what has been most useful for me. So let's go through these a little bit. The most important thing to me is flexibility, right? We are creating architectural spaces for people to live, work, play, do whatever in, and they're spending a lot of time in those spaces. So having well-designed lighting controls can maximize the usefulness of the space. Here you see 3 different lecture halls at University of California at Davis from a project that I had worked on with them some years ago. And what was really interesting is that not one of these spaces had very effective lighting controls. Now, if we were in person together, I'd ask you all the question, um, what is the number one way that lecture halls like this are used today? And we'd raise our hands and do all that kind of good stuff. But I can tell you now that if you look at projectors, there's a projection booth back here, projectors are the number one reason that you use these spaces. Now, the lighting controls in each one of these halls were such that it was basically impossible to dim the lighting effectively so that students could take notes while also not having the screen washed out by the lighting. So you had a choice. You could either take notes or you could go ahead and see the screen. Which would you prefer? So for the relatively short dollar installation of lighting controls in these spaces, the flexibility would be hugely enhanced. Now, I want to be clear. In each one of these cases, we're looking at fluorescent lighting. So it was a little bit more expensive then, not hugely more expensive, but it's more expensive than it is today. Understand that basically all lighting that you're going to find or specify or install today, it's all dimmable one way or another. Now that's not 100% true, but it is 98% true. So take it as written that dimming is a big part of what we're talking about. So what's next? Well, productivity. We know that a well-designed lighting system can increase productivity within spaces. We know this. This has been well proven with lots of research. So lighting controls ties directly into that by allowing us to do things like tune light levels, essentially adjust light levels up or down according to the needs of what we're doing within the space. They allow us to balance contrast and brightness, reduce glare, do all kinds of things, much of which leads directly into the whole notion of user satisfaction. Turns out we all like to have control of the spaces that we're in, right? Whether that's air or heat or sound or lighting. Anytime that we have the ability to provide dimming, particularly manual dimming, say in private offices, people tend to like that. People tend to value that. So that's a big plus. Maintenance. So LED light sources, which are basically our de facto modern light source, it's an electronic component. What is the number one enemy of an electronic component? Well, it's heat, right? So if we go ahead and dim the lighting, that's generating less heat at the junction point of the LED. That's effectively potentially extending the life of that LED. In fact, underdriving, this is what we call it, underdriving LED light sources, is one of the strategies that some manufacturers will try to employ in order to extend the life of the LED itself, particularly in places like high abuse environments where you have a hard time getting to the equipment in order to maintain it. So making use of some of the lighting control strategies that we'll be talking about can actually have significant positive maintenance implications for your projects. What about sustainability programs? There are all kinds of sustainability programs out there. It's not just LEED anymore. Built Green, Living Building Challenge, the Well Building Standard. There are lots of different programs out there. Basically, all of them will require you to have an advanced lighting control system in order to actually meet them. This is kind of a prerequisite. So if you're going to be doing any kind of sustainability on your building, assume that you're going to have networked lighting controls of some kind. Energy savings. So energy savings is, of course, a big issue with respect to lighting controls. Now, for any of you utility folks out there, of course, this is one of your primary reasons, right? Energy savings, dollar savings for any of the implementers out there for lighting and lighting control rebate projects, right? This is a big deal. The fact is, however, that for most of my projects, energy savings, while very significant, has been kind of viewed as the cherry on the cake rather than the primary reason for lighting controls. We tend to think of the other reasons as the non-energy benefits, right? Those become, from my perspective in the past, those are the real reasons to do it, because productivity gains, for example, really dwarf the potential for things like energy savings or kilowatt hour cost savings, right? But they are significant. So this will give you some sense of the types of aggregated lighting control savings that you might expect to find on a given project with a given typology for different rooms. And this is from the Bonneville Power Administration, BPA. This is essentially what most of the electric utilities in the area kind of base their rebate programs on when they're looking at energy savings. Now, I will tell you that it is aggregated. Some projects will give you more energy savings, some projects will give you less energy savings, but the savings are pretty well understood. You know, going all the way back to, there was a breakthrough study that was done by Francis Rubenstein from the Lawrence Berkeley National Labs in 2000 on a federal GSA office building in San Francisco that showed us fairly conclusively that we had very similar energy savings to what we're still assuming today with respect to these kinds of things. Now, I'll show you a case study, or a couple of case studies, where we have tremendously more energy savings. In fact, the DLC put out a study a couple of years ago, Design Lights Consortium, that showed us that there was kind of a bell curve of lighting controls savings on a lot of projects, right? So on one side you had, say, you know, projects that saved maybe 15, 20%. Some on the other side, you had projects that saved as much as 70 to 75%. And in the middle, in the sweet spot, was almost all projects, which were saving somewhere between 40 and 50% energy with lighting controls. So that should give you some sense of where we are there. Energy codes, right? In order to meet most modern energy codes, advanced lighting controls are required. The city of Seattle now requires, for example, in open office areas over 5,000 square feet, you're either going to use networked lighting controls or what we call luminaire level lighting controls. We'll talk about the distinction between those and what we mean by that a little bit later. But assume that if the energy code or an energy code is involved, you're going to be looking at these things pretty closely. And there are, of course, other reasons that we might be using advanced lighting controls, right? There might be very specific reasons. For example, research, right? If you are doing healthcare research, you may need to be able to very carefully control time of day, lighting exposure, or horticulture, things like that. Any others? Does anybody else out there have any other reasons that they'd like to share for why we might use lighting controls? If so, go ahead and populate that in either the chat or the questions. And before we move forward, I'm also going to say, are there any questions about some of the reasons that we might use sort of these lighting controls? Going to give you 10 seconds. Going to mute myself for a moment. All right, going once, going twice. All right, let's push on. So we've just talked about some of the rationales, some of the reasons why we would use advanced lighting controls. Let's spend a little bit of time talking about the very fundamentals of what we mean by lighting control. When I think of lighting controls, there's kind of three main aspects, right? Or it's sort of a little stool. The first of these, whoops, hold on one second. Somebody is trying to call me. Let's close that out. There we go. The first of these is the power circuit, right? So a power circuit, what do we mean by that? Well, it's essentially aluminum or copper, typically, in which we have electrons dancing back and forth on the line. I'm wildly simplifying this, but this is what delivers power to a lighting control system, to your light fixtures, to the toaster that you are using in the morning, right? So, oh, there's one thing before I dive into this. One of the other reasons property managers may like to upgrade tenant spaces for rent. That's another good comment, John, thank you. Why would you use advanced lighting controls? Because Class A office spaces are now assumed to have them. So that's a good reason for that. Okay, so back to this, power circuit. So if you're like me, you may have had a high school job at which you had to get someplace very early in the morning. Say, for example, if you worked at Safeway, right? If you worked at Safeway and you had to be there to stock the shelves in the morning, you might have heard at a certain time a ka-chunk sound coming from the back room somewhere. The ka-chunk sound was probably a contactor, which is, for those who don't know what a contactor is, it's basically just a big honking switch that a lot of power goes through, right? It's basically an automated relay. So what that is doing is delivering a whole bunch of power to a whole bunch of light fixtures out in the parking lot, either turning them on or turning them off, right? So in that particular case, we're controlling a whole bunch of light fixtures by turning power on or off at the circuit, right? Another way to think about that, my job, I was one of those people, some of you may have seen the commercial, time to make the donuts. Well, at 5 something in the morning, I would pedal my bicycle to Mr. Donut, and one of my jobs was to go in and turn on the lights for the front of the store. Of course, there were no light switches. I had a panel, load center and a bunch of circuit breakers. And of course, they were switch rated circuit breakers, right? So I would go in, I would click them on, circuit breaker on, adding power to the circuit, circuit breaker on, adding power to the circuit, basically controlling lighting that way. It's kind of the original, mad scientist with a knife switch way to control lighting controls. So I'm going to make a case as we talk about this stuff that we no longer really think about controlling lighting as power circuits anymore. Typically for lighting controls, we have semiconductor devices that actually have logic associated with them. So we tend to keep the power circuit hot all the time, and we control the lighting more finely using the idea of a control zone or a channel. I will tell you before we get going too much on this, one of the problems that the lighting industry has today is a lack of common nomenclature. I did a study last year and a half ago, in which I discovered that many manufacturers use different words to talk about the same things, right? So I'm gonna use the words control zone or sometimes I might use channel, because channel is the theatrical term, and all lighting controls kind of flowed from theater. But a control zone is essentially a logical grouping of light fixtures that are controlled together, right? They might be on the same power circuit, they might not be on the same power circuit, right? But no matter what happens, they will all turn on together at the same time, they will turn off together at the same time, and if there's dimming involved, they will always dim up or down at the same time at the same rate, right? If there is ever a time that this light fixture and this light fixture want to do something different, they have to be on different control zones. It's not possible to break that. Think of that as the atom of the lighting control world, even though I understand that there are particles smaller than atoms now, but it's usually not a good idea to break them apart. So the biggest error that I find in lighting controls is that people tend to put things together that shouldn't be on the same control zone. So this is an example. This is the Reebok World Headquarters back in Massachusetts, a project from many years ago. You'll notice from the sort of spaghetti control zone nomenclature here that we all used to use, the spaghetti lines, that each one of these light fixtures that are these 4-head accent adjustable recessed fixtures have 4 lines going to them. That basically means is that each one of these lamps is controlled individually. Now these are metal halide, the ceramic metal halide from years ago. So the control is switching on and off. Now the reason that we would do this is so that we could have multiple light levels within this basketball court, because sometimes it's just used by a bunch of people playing basketball that we see here. Sometimes it's used for convocations. Sometimes it's used for award ceremonies. Sometimes it's used for NCAA level play that's actually being recorded. So there are a lot of different potential uses here. Independently zoning them allowed for multiple light levels, multiple uses within the space. Today, we would use LED, we would simply be dimming. There would be one control zone each, and we would just dim the whole fixture up and down. I hope that makes sense to everyone. So how do we start to apply this? Here's a couple of examples. This is from the North Seattle College Allied Health Building. Completed, I don't know, 2012 or so, 2012, 2013. I will qualify and say that this is still fluorescent, right? This was on the cusp of when fluorescent and LED kind of made sense to go one or the other. But everything in these classrooms are dimmable. So you'll notice that these indirect direct pendants are these indirect direct pendants. This wall washer is this wall washer. This window wall is this window wall. So I hope that orients you a little bit to the space. Now, from a control zoning standpoint, well, how have we got this set up? Well, we've used in this case a room-based nomenclature, right? So this particular system is room-based. It's networked within the room, but it's not networked within the entire building. And I'll show you what I mean differently on that in a moment. So in this particular case, we have zone A. Zone A is these light fixtures, which are basically this row here, which are closest to the teaching wall. Zone B is a little bit back here. Zone C is the wall washer at the teaching wall. Zone D is the perimeter. Zone E is some under task lighting that you don't see here, right? So this particular project is full dimmable, has you'll notice passive infrared occupancy sensors. It also has a photo cell, so it's got daylight control. This has everything that we would expect to find in a modern networked lighting control system, the fluorescent kind of space. Why would we do it this way? Well, remember I showed you the UC Davis lecture halls, particularly with the inability to dim the lighting that would be washing out the screen, you know, washing it out kind of like this, right? This allows us to dim the lights at the front that are closest to a potential projection screen. So you have a projector here, to dim them way down, to dim the rest of the lights at a different rate so that students can still go ahead and take notes, do what they need to do, and still be able to see the projection quite effectively. I hope that all makes sense to everybody. Now, again, if people have questions as we're moving through, please go ahead and put them in the chat. Now, this is an example, as I've mentioned, of how we would annotate a room-based control system. How might we annotate a larger system, one in which the specific rooms are all communicating to a central system? This is a project that was done a couple years ago. This is the Washington State University Troy Hall building. This was an adaptive reuse of what was originally their dairy building that I think was built in 1906, if I'm remembering correctly. But you'll see the old building here and behind, and this is a projection of sort of pushing out from the building with a modern side on the north side, I think, if I remember correctly. Regardless, the astute observer will notice that this line of light here showing up under a stair is in fact this line of light, right? These linear fixtures in this office are these linear fixtures, and so on, right? So give you some sense of where things are. Now, you'll notice that what I have here from a zoning annotation standpoint is the letters Z1, zone 1, the 1 is floor 1, 26 is zone 26, zone 33, zone 27. I hope this is making sense. So I have a 5-story building, and I have zone Z1. This is the first floor. If we went up 1 floor, we would have Z2, we'd have Z3, we'd have Z4, right? That's how I annotate control zones in order to make things very clear for installers, for users, and for programmers as the systems are going through. And you'll notice another thing here. None of the light fixtures that are of different types are on the same control zone, right? I have this linear LED here, close to this linear LED here, but they are on different control zones because there is a likelihood that I may want to dim this to a different level than I may want to dim this, right? Both from a time of day standpoint based on available daylight, but also potentially from the amount of light that I need in order to fine tune the lighting within that space, right? So I hope this becomes clear. There are many different ways that you can show lighting controls. This is just one of them. The last version showed the A, B, C, D method, which works pretty well when you have individual rooms, right? When you have a larger control system like this, if you don't have some kind of logical way to annotate them, it gets very scary very fast from a how do you keep order standpoint. Now, sometimes people ask me, what kinds of lighting control systems that I have gone ahead and designed. The smallest control system that I've ever designed was actually for 2 Nobel Prizes over at Fred Hutch, right? It was basically an on-off light comes on, lights up the medallion. The largest control system I've ever designed was a fully integrated 20-building college campus over in Saudi Arabia. We used this same kind of nomenclature on the project in Saudi, and I can tell you it saved my butt. Keeping things very well organized that way. So in that particular case, we simply added another numerator before the floor number. So in that case, it was Z-1 through 20, depending on which building it was happened to be in, and then dash what number floor, and then dash what number of control zone on that floor. So it can get very complicated very quickly from a keeping track of things standpoint, but trust me, you really, 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 really want to. So I hope that all makes sense for everybody. Let me go through a couple of more examples. This is a fairly atypical space. This is Canyon Ranch Spa down at the Venetian Hotel in Las Vegas. Canyon Ranch is one of those places that you can go and they will give you all kinds of spa services. Wonderful, wonderful place. This happens to be the relaxation room, right? And the idea is that you'll have just done whatever treatments you're going to do, and you'll come to a space that is very calming, and you'll spend some time in there. So one question about something like this is, how might we approach control zoning for this? Well, I'm going to tell you, this was a while ago. I don't remember exactly how many control zones are in here now. My memory says, well, I'm going to skip how many my memory says, but I'll tell you what I would do now, right? So this is a linear wall washer, right? There is a linear LED wall wash. You can actually see some reflection here. You have 2 different types of wall, right? You have a textured white wall and a polished marble wall between the 2. So I would consider this to be 2 control zones. Control zone A, control zone A, control zone B. Why? Because in a space like this, it's a very high-end space, I want to be able to balance the visual perception of those different materials in order to emphasize again, the flexibility, the usefulness of this space. Some other lighting that's in here, there's a fake Oculus here. This is actually neon, but today we would do it with LED, and I would want to have control of dimming that. One thing you can't see is that there are some theatrical spotlights tucked up in here, giving you these kind of patterns on the floor, right? So that would be another control zone, would be to control those. There are accent lights on the water feature. We would have a different control zone to control those. And then we have these decorative custom pendants that are here. And I would want to control these in groups of clusters, right? So control zone, control zone, control zone, control zone, all so that I could visually balance this very high-end space in order to maximize the flexibility, the productivity, the user satisfaction, all of those things, right? Now this, again, I don't want to scare anybody with control zoning. This is a very sort of specific kind of space. How about a more prosaic space? This is an elevator lobby, 1111 3rd Avenue in Seattle. This was completed, let's say 8 years ago, 7 years ago. Everything you see here is LED, right? Now, if we were together, I would ask you, how many control zones do we think we have in this particular space? And people would guess however many, but let me walk you through it. So we have an elevator core here. In fact, there are 3 elevator cores. You can only see 2 of them. We have a wood wall here. We have a textured wall here that's not terribly dissimilar to what we saw at Canyon Ranch, right? So we have an LED slot that goes all the way around. And I would ask you, how many people think this should be 1 zone versus 2 zones? And we would have this discussion. And I'm just going to tell you that it really should be 2 zones. In fact, we designed it as 2 zones, and it got value engineered back to 1 zone. Problem was that the perception of this white wall was so different than the perception of this wood wall that it caused a lot of problems. It was something that was very unfortunate. There were some other issues involved with the perception of white versus the perception of the color of the wood, something that we call metamerism that we wouldn't really, we're not going to get into today. But suffice to say that it would have been tremendously better if they had stuck with the original zoning of grazing material, grazing a different material, right? So that would be a way to do it. So we would have 2 control zones here, right? We would have a different control zone for the back of the security desk here, because we would want to potentially have this dimmed at a different level than we would have this. We have these downlights, different control zone. We have these downlights, different control zone. We have this backlighted panel, a different control zone. Now, I'm intentionally avoiding the discussion right now of emergency lighting, because technically some of these will be emergency lighting and they will also be on their own control zone, right? They will be grouped together so that they all dim up and down, and we'll talk about how that works in a little bit. But this is going to be something that we jump through. All right, so let me jump away from control zoning to the 3rd element of the stool, right? So we've got circuit, we've got control zone, and then the 3rd element, or the 3rd really fundamental lighting control issue, is the idea of scene. Sometimes it's called preset, sometimes it's called a look. And that's the idea that within your visual field, right, you have a variety of control zones, and those control zones are set at certain values. They might all be 100%, all full bright. Some of them might be at 50%, some of them might be at 70%, some of them might be 100%, and those values might shift over time for specific reasons, either visual reasons, daylight, whatever they happen to be. So a scene is essentially a programmed collection of lighting control zones that are repeatable, right? So here we see a boardroom that has 3 different control zone, 3 different presets that are showing for different things, right? We might have a presentation mode, we might have a teleconference mode, we might have a face-to-face meeting mode, whatever that happened to be, and we might want to have different looks or different lighting aspects within that specific thing. Now, there's also an idea that we call a fade rate. So we've all been places where the lights change very quickly, right? And that's a little bit jarring. So let me give you a quick example. We've all been to a bar, or presumably some of us have been to a bar at happy hour, and we're after work, we're visiting with our friends, we're visiting with our colleagues, and we've just had a quick drink. Okay, that's fine. So then somebody walks over to a comprehensive, really well-designed lighting control system like this and starts fiddling with the knobs. And what happens is lights change, right? So lights immediately, well, that doesn't go as, lights do something that you notice, right? So when you go ahead and do that, you notice it, right? So what happens if you're having that happy hour drink with your friends? Well, you probably look down, notice on your wrist that, okay, it's gone from 4 o'clock to 5 o'clock, 5 o'clock to 6 o'clock, whatever that happens to be. And instead of going ahead and saying, yeah, sure, I'll have another round, you say, no, I've got to get home. So think back to productivity, right? So the idea of productivity from the perspective of the owner of the bar is how many drinks they've sold. So here's a different example of that same kind of bar. This is a Semiahmoo Resort up at Blaine, Washington. It's a project we did with GGLO some years ago. And essentially, the lighting controls in this space are automated, right? So we have a very complicated space here. There's a lot of daylight. The space opens for lunch, open in the afternoon, open for dinner, and sometimes they actually have music in a corner. So there are a lot of things going on in a fairly visually complicated space. So we actually have, I think it was 8 presets in this particular space. There's one for morning, right? So when staff comes in the morning, everything's bright so they can clean up, they can set up, they can do all of that stuff. Then there's a lunch preset, a mid-afternoon preset, a later afternoon preset, an evening preset, nighttime preset. There's one for having a performer in the corner, you'll have a guitarist, whatever it happens to be. And the idea is that this automates, right? So except for maybe some kind of special occasions or something, the staff doesn't have to do anything. This all is pre-programmed so that over time, we fade from one scene to the next scene, to the next scene, to the next scene, so that nobody notices that anything is happening, right? You never get that moment of something changed, head snaps up, look at the wall. It becomes easy for the staff as well. So this is kind of a quick example of that. Now we are going to do a pop quiz. You didn't realize there were going to be quizzes. And then we are going to stop for questions. I hope that all makes sense for everybody. The whole notion of control circuit, power circuit, control zone, and scene. So what are some of the reasons that we might want to use advanced lighting controls? From your perspective, what are some of the reasons that we might want to use them? Flexibility, user satisfaction, increased productivity, they add complexity, energy savings. What are the things that are important to you guys, right? Again, I gave you the list in my order of things that have been useful for me in that order for getting owners and clients to understand the value of these systems. That order may be different for you, and that's okay, right? You guys all need to decide for yourselves what is most important to your clients and how best to implement these systems for yourselves. All right, we'll give you guys just another couple moments here. Do 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 do. All right, most of you have voted, so we're going to close this. So let me share the results. So from your perspectives, what are some of the reasons we might want to use the controls? Big bunch of you said flexibility, and a big bunch said energy savings. Of course, both of those are very important. User satisfaction and productivity, from my perspective, go hand in hand. I usually talk about them separately, but a big part of the increased productivity is visual comfort. But another big part of productivity is, let's face it again, people like to have control. People are happier. If you're happier at work, as we all kind of go back to our offices, if you're happier there, you're going to be more productive. That's kind of basically the way it is. So I hope that this is all useful for you. I'm going to hide these results, and I am going to go to questions as long as we have the pop quiz going. So there are a few questions here. Let me jump through them. What is the simplest software for this layout? That question came in when we were talking about the lighting control zoning. And I don't know that there is necessarily a simplest software for layout. Some manufacturers have software that they think is automated for being able to set up and design systems, but I'll tell you, my experience has been that really only becomes useful for very, very simple systems. Like if you were doing the one room for the control system for the North Seattle College, right? That particular system, you could use one of several different manufacturers' sort of layout software, and that might work. But honestly, there aren't really a lot of shortcuts when you're talking about systems that are larger than a single room. So it's really in the particular case when that question came in, the tool that was being used in that case was Revit. So AutoCAD and Revit tend to be the things, and then just keeping track of the control zoning itself in Excel is usually the way I do it. And I'll show you examples of that, by the way. Other than the backroom time and organize and note zones, the incremental cost of extra zones is near zero, correct? So I think interpreting the question, so adding extra control zones to a project can potentially add cost. The cost is relatively minimal today compared to what it's ever been in the past. But if you are using a networked lighting control system, you would need to have a bit of additional hardware in order to control things independently. So that's one of the values of what we call luminaire level lighting control, in which each light fixture is its own control zone. We'll see examples of that. Value engineering is not much of an issue for LED, correct? Oddly enough, value engineering seems to not be going away. So for those of you who don't know the term value engineering is basically the idea that you're trying to maximize the value for the owner. From my perspective, value engineering that happens during the design process, when you're essentially right-sizing lighting, controls, all the building elements, is hugely valuable. Value engineering that happens after the design process, which is simply a way to cheapen the job, is an oxymoron, because it's neither valuable nor is it engineering. So that's simply my sense of that. One reason for fewer zones is for simplicity. Users need easy to understand controls. Don't misunderstand this. The more control zones you have doesn't necessarily mean that there is more complexity from the perspective of the end user. You can, the whole notion of scenes, right? I can take 30 different control zones and aggregate them into 4 different scenes, and the only thing that the end user sees is the 4 different scenes, right? They don't recognize that there's necessarily a lot of different things happening. So the complexity from the end user standpoint is all about the human interface stations, basically the button stations and how they're programmed, right? The complexity of the control zoning is all about maximizing flexibility. Now, I will say that in general, I do try to economize on control zones wherever I can, but I make sure that I always have enough to accomplish whatever the visual task that I'm actually trying to do is, right? And I never, ever, ever put different types of light fixtures on the control zone. A wall washer should never be on the same control zone that a downlight's on, if that makes sense. And the last one here, whoops, end up with better lighting in each space closer to the state of art provides value, makes me look smart too. So the interpretation there is better lighting, better controls makes everybody look better from the perspective of the owner and the end user. If we all work together to effectively to create a wonderful space, it's going to be a wonderful space. Everybody's going to love it. All right, moving on. So we've talked about some of the reasons that we would use lighting controls. We have talked about the fundamentals of lighting controls, right? Again, the circuit, how do we get power to the light fixture? The control zone, how do we make the fixtures dim up, dim down, turn off, turn on? And how do we aggregate them together into a scene or a preset or a look in order to make the whole visually correct, right? So those are the basics. Let's talk about some of the actual lighting control strategies that might be implemented using those three elements, right? So these are the typical lighting control strategies that I've been teaching for actually 30 odd years, right? There is literally nothing new in this list. Some of these are easier than they have ever been before and less costly than they have ever been before. Astronomic scheduling we'll talk about, for example. That used to be a specialty kind of a thing. Now it's just in basically every kind of lighting control system. But understand that these are not individual control strategies for each project. In other words, you're going to aggregate a bunch of them. This particular project, San Francisco Public Utilities Headquarters Committee, San Francisco Public Utilities Commission headquarters down in downtown San Francisco. It's a 14-story urban office building, right? Every single one of the control strategies that is listed here is used on this project at one place or another, right? Manual switching, dimming, preset control. Let's talk about some of them, right? So manual switching, we all understand, right? You go over to a toggle switch or a paddle switch or some kind of relay. You hit the thing, lights come on, lights come off, right? There's no manual up, down, it's just on or off. Now, in the old days, we would typically see this with line voltage, right? We would have a circuit coming in, the circuit would be interrupted, and the circuit would then continue when the switch was flipped, right? So this was a circuit-based level of control. Today, we're basically doing this electronically with semiconductor devices so that we're not generally interrupting the power so much as we usually are communicating from a wall station device to a system or directly to something at the light fixture that will then say turn on or turn off. So it's not really that, it's a zone-based system rather than a circuit-based system. Manual dimming simply gives us the ability to raise the lighting or lower the lighting. And again, typically in the past, we would have a power handling device in a wall that would essentially change the nature of the current going through the system, right? It was essentially turn on and turn off very quickly in order to change the power going to the light fixture. We'll talk dimming 101 in a little bit if that doesn't make sense to you yet. But today, again, we're largely talking about the notion of being able to do that via communications to something at the light fixture. Scene or preset, again, just the ability to take those zones, aggregate them together, and have something happen in a programmed kind of manner. Now, in the old days, we would have very expensive devices like this, in which we would have individual control zones that we would program, and then we would press these buttons in order to activate them, or buttons like this, or in this case, this is a touch screen, right? Now, the thing is, we don't typically with network lighting controls need to have big expensive equipment like this anymore. Now it's largely a matter of programming once we have the gear. What do I mean by that? So a modern network lighting control system typically consists of some kind of load controller, right? This load controller talks to the light fixture. It receives signal from a wireless or a wired communications device, and the load controller tells the light fixture to go up or down. So what we have here, these are some demonstration boards that I designed and built a few years ago to demonstrate how to program some of these lighting control systems, right? So if you think about this, this is basically building wiring writ small, right? So we have a junction box, we have through wire from a load center. So we've got a hot and a neutral coming through wiring box to box to box, just like we would in a normal building. The biggest difference is that there's a 2-inch gap here between boxes instead of a 10 or 12 foot gap between boxes, right? And then we just go up to our light fixture. So in this particular case, then, we have the ability with just the same little kit of parts to do manual switching, on off, dimming, up down, scene control. Let's see how that would work. So I've got a switch. I've just turned everything on. Now I'm going to turn everything off. So there's our manual switching, wireless communication between the device and the load controllers. Now I'm going to dim one control zone. You'll notice each one of those load controllers is a control zone. So each one of these light fixtures is its own control zone in this particular case. I could control multiple light fixtures from one load controller if I wanted to, but every zone has to have its own load controller. I hope that makes sense. So now I'm going to dim the whole aggregate bunch with scene control, right? So you'll notice I'm actually engaged in dimming raise lower for the whole bunch of them. I'm going to turn it off. And now I'm going to go ahead and activate the scene control. Scene 1 is all on at some preset level. Scene 2, scene 3, and off. Now, I want to draw a significant distinction for you here. With respect to this kind of idea of networked lighting controls or programmed networked lighting controls like this, all of the capability that you've just seen there is accomplished with basically the same kit of parts, right? You have a load controller, right? The load controller is what tells the light fixture to dim up, to dim down, right? You have some kind of wall station. In this particular case, those are the little switch stations, right? Those would typically be mounted on a wall, so you walk into the room and you do whatever you're going to do. The programming for the scenes is all done sort of behind the curtain, if you will, right? With an app using a smartphone, so that all of this stuff comes together. So with the same kit of parts, we have manual switching, manual dimming, and preset control, all of these things together. And the thing is, each one of the switches that does different things, they cost basically the same thing. So if you want to have manual switching, you can have manual switching. If you want to have manual dimming, you can have manual dimming. If you want to have preset control, you can have preset control. It's all about the same cost, plus or minus a very small amount. There's no more of that shilly-shallying about dimmers are more expensive. Scene control is more expensive. What you really need to start thinking about for your clients is what is the best use for the clients, right? How can we most effectively do that? Okay. I'm going to ask the question, does anybody have any questions about this before we move on? I'm going to give you just a couple moments and then we'll dive through. The red one. I'm going to talk about the red one a little bit later. Okay. All right. Moving forward. So those were switching, right? Switching, dimming, scene control. Occupancy sensing, right? We all understand occupancy sensing, the idea that you walk into a space, lights turn on, you leave the space, lights turn off after a certain period of time, right? Now, the difference between occupancy sensing and vacancy sensing is that with vacancy sensing, you go ahead and you press a button first before the lights come on. They don't automatically come on. Now, those are two very different sorts of things, but the interesting thing from a design standpoint or installation standpoint, with the exception of one manufacturer that I can think of, basically the hardware is all the same, right? And whether it's a vacancy sensor or an occupancy sensor is either a toggle switch on the device itself, or more frequently now, it's simply a programming trick within the app that programs these things on your smartphone. And it can change during the day, right? So that at certain times of the day, for example, during business hours, your open office lighting might be governed by a vacancy sensor. At night, it might be governed by an occupancy sensor. It's just a quick programming trick, right? So what about some of these things? A couple things to think about with them, right? There are two dominant flavors of occupancy vacancy sensors out there, right? Passive infrared is basically just, think of it as an infrared camera that's segmented, right? And what it's doing is it's looking for motion of a heat signature across multiple parts of that segment, right? Now, passive infrared sensors can be wired or they can be wireless, right? They can be battery operated because it's passive. It's not actually emanating anything into the space. The other dominant flavor is ultrasonic, right? Ultrasonic essentially is a device that emits a very high frequency ping, and what it's doing is listening for a bounce back of that signal within that space, right? So it's going ahead and listening for Doppler shift. If there's motion in that space, there's going to be attenuation of those sound waves, and it's going to give it a Doppler shift. Now, two things. Passive infrared can be battery operated, but it's line of sight, right? So if you have, say, a toilet stall, it's not going to see through the toilet stall. Ultrasonic can go around corners, right? As long as there's not a lot of other things like heavy airflow. If you have heavy airflow from an HVAC system or something that will get the air roiling, that might cause false triggers in an ultrasonic sensor. There are also dual technology sensors that basically use passive infrared and ultrasonic. And the idea was in years past that if we had both technologies, that would limit the number of false triggers off. I will tell you that in most cases now, I just prefer to use passive infrared. Why? Because if I have a wireless device, most of the things that I do are wireless. I can just take a wireless sensor, put them up wherever I need to. They're relatively inexpensive. If there's some kind of problem, there's a job site change, or now there's a visual obstruction, I can either just add another wireless sensor. They're very simple to install, right? Or I can move it, right? If I have a wired sensor, like an ultrasonic sensor, it has some difficulties with respect to moving it. And of course, the ultrasonics have to be wired because the active nature of them would exhaust a battery very quickly, right? So these are some that look like the dual technology kind of things. Now, there are other sensors out there, right? There's a technology called microphonics, which basically is, as I understand it, listening and developing a sound pattern for a specific space and looking for changes right within that sound pattern. There are microwave systems, there are radar, LiDAR systems that are being used particularly for exterior. Whatever you're using, the most important thing about an occupancy or vacancy sensor is this. There's going to be a coverage pattern that you're going to find on the cut sheet. In this particular case, for example, this is a forward-looking sensor. You'll notice two things. There is a far band and then a closer band. What these are doing is they're showing you what is the fine motion range and what is the gross motion range, right? Some sensors are good for 500 square feet. Some are good for 2,000 square feet. Some are corridor based, so that they're going to look in a corridor kind of configuration. Whatever you're using, you have to pay attention to those sensors and confirm the coverage area, confirm the range. The number one problem that I see with respect to occupancy sensors is folks not realizing that they needed to pay attention to the actual coverage and overlap that coverage so that they didn't have gaps in that coverage. I hope that makes sense for everyone. The other big thing that I see is line of sight, right? So this is a classic example. I see this all the time, in particular in college campuses, right? So you'll have a professor's office, they'll put a bookcase in, they've got one of these wall-mounted sensors, right? Put a bookcase here, suddenly you've occluded the view of the desk that's in the corner here, so it might false trigger off because it can't see you. If you can't see the sensor can't see you. That's kind of the way that that works. So the solution here would be to either put a sensor up in the ceiling or to use an ultrasonic instead of a passive infrared sensor, so that the occlusion here visually wouldn't matter as much. I hope all that makes sense. All right, so there are many different ways that you can configure these things, right? But commonly speaking, you're gonna either have wall-mounted sensors, right? You're gonna have ceiling-mounted sensors, or sometimes you'll have sort of oddity kind of places, but generally speaking, you're gonna be looking at either the wall or the ceiling. Now, my personal preference, again, is to go up into the ceiling whenever I possibly can, unless there's a very specific reason otherwise, right? Because the ceiling has the largest field of view within that space. It can see most things. I hope that all makes sense. Now, the next strategy that we might look at would be daylight harvesting, right? And this is the idea that we would go ahead and have a sensor within a space that's sensing the ambient light level within and adjusting the electric lighting accordingly based on how much daylight happens to be available. Now, there are two flavors of how we do this commonly. One we call open loop, right? And the idea is that the open loop sensor is looking outside. It's looking to see what the sky condition is outside, and we would mount that either looking out a window or up into a skylight well, something like this. So in these two cases, this is University of Montana Rec Center. We did this a number of years ago. There's a sensor up in the ceiling here looking up into the skylight, and it's telling us how much light is available there. And in this particular case, these light fixtures were switching. They would have 4 different light levels based on the availability of light within that space. This is the King Abdullah University over in Saudi Arabia. This is a library. The daylight sensor here is tucked up into this light well, and again, it's looking outside and it is dimming the lighting within the library accordingly. Now, the other flavor that we might use is something called closed loop. Now, what that means is that it's basically looking down at a work plane and it's trying to maintain a specific light level at that particular work plane. Now, there are pluses and minuses to both of these approaches, right? Most commonly when I can, I tend to prefer open loop. And that's simply because if you're looking outside, you're likely to be seeing the same thing long term. What do I mean by that? If I've got a closed loop system, I'm looking down at a work plane, right? Now, when I program the system, my work plane might look something like this, right? What happens if the desks move and suddenly the work plane looks like this? You're going to wind up having a very different set of inputs coming back into the system from the control zone from the photocell controller. So in order for that to work optimally, it would need to be reprogrammed. The chances that it's going to be reprogrammed is pretty slim. So unless I'm talking about luminaire level lighting controls, which again, we keep talking about LLC, we'll get into that shortly, I tend to prefer the open loop, but you'll go ahead and choose as you see most fit. Some manufacturers actually have combined sensors that kind of look outside and kind of look towards the work plane, and then do some kind of magic algorithm that allows them to function sort of pretty well in both worlds, right? So think of that. So another one of the strategies that we tend to use is the idea of task tuning, or sometimes we call this high trim. And the idea is that most of the time, lighting is over-designed. Why is that? Well, because over time, light fixtures will decrease their light output, and most lighting designers will also put in a little bit of a fudge factor so that we can accommodate for potential job site changes. Maybe the carpet got darker, maybe the walls got darker, who knows what it happens to be. But the reality is, if we have a target light level, most of the time, the initial light level of a lighting control system is 25 to 35% higher than that, right? So that's a big chunk of energy that can be saved right off the bat by right-sizing the lighting from the very beginning. This is example bullet center. This used to be my offices when I was with PAE engineers. Part of the design here was that I intentionally over-designed the lighting, in part, again, for maintenance, so that I would be under-driving the lighting control system so that the light sources would last longer, right? So going ahead and bumping that down by 30%, 25 to 30%, cut the glare, right-sized the lighting, saved 25 to 30% of the energy, did all of these great things, and gave me maintenance. Problem with task tuning and high trimming is that a lot of times people forget to do it. This is one of the most important things to do. A specialty subcase of this is something called adaptive compensation lighting. When you walk into a grocery store at night, if you have what I used to call the Safeway squint, ow, the light's bright. That means that there's too much light, right? You can dim the light very significantly in these kind of places at night because our eyes are adapted to darker lighting conditions. Said differently, we need less light at night, right? This is a simple fact. So working with companies like Whole Foods and like Safeway, we worked with them pretty significantly over the years to look at ways to go ahead and use this adaptive compensation with dimming control systems or multi-level switching systems to go ahead and reduce. And this is a special case of this idea of task tuning. Next one is time scheduling, right? Certain time of day lights go on, certain time of day lights go off. Now, this used to be one of the most important ones of our control strategies, right? Particularly for things like offices. But today I'm finding that we tend to control even open plan offices with occupancy or vacancy sensors rather than time scheduling, because it's much more effective at actually saving energy than time scheduling. So scheduling tends to be used actually by people like me more to fine-tune lighting control systems, things like telling an occupancy sensor to be an occupancy sensor versus a vacancy sensor, right? So those are key issues there. A specialty subcase is the idea of astronomic scheduling, which basically you put in your longitude and latitude within a given space, and it calculates sunrise, sunset for you. So this is fantastic for things like campus walkway lighting, building facade lighting, things like that. Places where you want light to be unitary. You want it to come on at the same time, you want it to go off at the same time, however that kind of happens. So this used to be a very exotic kind of thing. the manufacturers used to actually sell specific, $3,000 modules to make this happen. Now it's simply a little toggle that you deal with in your programming, much like the whole idea of switching, dimming, scene control from the same devices. Everything is now all about programming. Load shed or demand response. So this is the idea that some of you will remember the California brownouts in the old Enron days. This kind of is where this comes from. The idea that large facilities can save enormous amounts of energy very quickly by dimming or shutting off lighting accordingly, right? Originally it was shutting off lighting. Now it tends to be dimming lighting. So the idea is, let's say there's going to be a brownout. The electric utility can contact a facility and say, please cut your lighting load by 20%, whatever it is. We can dim that load now. Instead of turning things off, we can have minimal impact on productivity simply by dimming rather than switching. And with the open ADR protocol, that can happen automatically. Nobody actually really particularly notices. Now, one of the key reasons for doing this these days actually happens to be cost, right? So electricity on the wholesale market will change value very significantly depending on time of day. So smart buildings, as we move forward into the whole idea of smart grids, smart meters, smart buildings, will give you the ability to adjust not just your lighting loads, but your lighting, your car charging, your refrigerators, whatever, based on time of day charge rates. So you'll be able to modulate the energy accordingly so that we maximize effectiveness of the grid. If you want to learn more about this, check out openadr.org. There's a lot of great stuff there. Now, one control strategy that we never want to see anymore is this. I still see people asking me about bi-level switching. Please don't. If you are going to have an LED light source, an LED light source is going to be dimmable. Switching lighting, bi-level switching lighting just gives you that something changes very quickly and irritates people. Just go ahead and dim, right? So no more bi-level switching, dimming, 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 dimming. Now there are some newer control strategies out there, and they're all predicated on the whole idea of LED and LED technology capabilities, right? Color selection, tunable white, all these kinds of things. Now this is a great example. This is something we did at Children's Hospital. We'd originally wanted to have a circadian lighting control system at Children's Hospital, but it proved to be too expensive. Now this was going back a number of years. It's not so expensive anymore. But what we kind of ratcheted back to was the idea that we would have color tuning LED at the wall here, and the kids can choose what color they want. It's really just a way for the kids to have some control over their environment, because these poor kids are here for however long they are for their treatment, and it gives them a little bit of control over the environment. Again, user satisfaction, something to play with, right? So color selection, we can use colors for a lot of different things. These are cubes over at the Microsoft campus. They're internally illuminated 27-foot cubes that will change color, and they are meant to certainly be iconic, but they're also meant to emphasize vertical circulation and to get coders to climb the stairs rather than ride the elevators, right? So there's one issue. Another version of this is the whole idea of tunable white warm dim, right? So incandescent lights, when we dim them, they exhibit something we call red shift, right? The lights get warmer as they get dimmer. So LEDs don't do that. Fluorescent doesn't do that, except if we've got multiple color chips in the light source, they can go ahead and be programmed to go ahead and do this. Very useful for residential, for boutique retail, for hotels, places like that. Intentional tunable white is the idea that we might have color chips from very warm to very cool, and being able to modulate the percentage of how much we have tells us that we can go from high correlated color temperature, very blue light, down to very warm correlated color temperature, very yellow amber light. We might do that for aesthetic reasons. We might do it to affect mood. We might do it for what we call circadian lighting, right? Now, there are a lot of different reasons for this. Some of these are really, frankly, just aesthetic, right? We might prefer 2700 Kelvin relatively warm light. We might prefer 3500 Kelvin. Big software company over in Redmond, for example, their standard for years was 3500 Kelvin relatively neutral, because that was when they got the least complaints, right? But these kinds of tunable light systems allow us to go ahead and select from the different color temperatures that we might like. Now, if we add some intention to that, we might try to do things like modulate our attention, modulate our mood. In schools, there's a lot of research going on that's talking about using color temperature to be able to make kids more alert, make kids less alert, make kids more engaged, make kids less engaged, depending on what we're trying to do, right? Now, I will say that the research is kind of going on out there, and it's not just color temperature, it's also intensity, right? Now, if we're talking about adding then in automation, we get into things that we might think of as circadian controls, right? We know for a fact, for example, that light affects our chronobiology, right? And there are a number of different elements to that, right? There's time of day exposure, there is intensity exposure, there's color temperature or spectral character, right? How much blue, how little blue, for example, light has. There are a number of different things that we might look at, but without getting too deeply into that, lighting controls can actually modulate 4 out of the 5 key variables. So this is one of the reasons we might start to look at some of the newer control strategies. And then there's architainment, right? So we'll talk a lot about, we're not going to talk about this, but there are things that you can do with that stuff. So with that, I'm going to take a brief pause. Are there any questions about what we've just talked about? Thrown a lot of information at you very quickly. What is an appropriate lighting reduction for adaptive compensation in grocery stores? That's an excellent question, and there is no perfect answer for that. So the question is lighting reduction for adaptive compensation in grocery stores. The key thing is to figure out what you want your target light levels to be at various times and then dim accordingly. I will say that when I was working with Whole Foods years ago, what we found was that we could reduce lighting by between 30 and 40%, depending on their particular stores, and that would be appropriate, right? That would give you appropriate vision within those spaces. But that might also speak to the fact that their stores were a little bit overlighted to begin with. I had a meeting with the Safeway CEO a number of years ago, in which he wasn't really thrilled when he discovered that I used the term Safeway squint, based largely, some of you may remember the old Safeway store up on Broadway, up on Capitol Hill, that was so radically overlighted that it actually hurt to walk in there at night until your eyes would get adapted to the high brightness, right? And I don't remember what the light levels were in there, but I would say probably, you can be looking at somewhere between conservatively 25 to 35% energy savings in those kind of cases. And John, I got Don Norman's design book, recommend to all. John, I will remind me a little bit later, and I will try to talk about that. Okay, I'm going to zing through some more stuff here. So we've talked about why, right? We've talked about the basis. We've talked about some of the how. Let's talk a little bit about some of the what, right? So when we're talking about all of these things, we're talking about a very big evolution in hardware. I showed you some of the examples of the load controllers rather than the sort of wall switches, right, that we use these days. And that's all been kind of the same evolutionary path that's taken us from the mad scientist with the knife switch all the way into now being able to control lighting from computer routers if we want to, right? But the whole sort of pathway, one to the next, is this whole notion of analog to digital, right? So if we think about the gear, if we think about the equipment, the hardware, if I asked in our class, how many of you out there have had a lighting control failure in your lives? Every single one of you would raise your hands, right? And then if I asked the same question, how many of you out there have had trouble, I mean, Verizon's issues yesterday notwithstanding, how many of you have had trouble with your smartphones today versus say 20 years ago? Most of you would say that these are pretty seamlessly plug and play today, right? Now, this is true of basically all electronic components, right? 25, 35 years ago, we had lots of failures with some of the electronic components for lighting controls. I did a project, I can tell you, with a major East Coast manufacturer, Bank of Boston project in the late 90s, in which the then digital fluorescent dimming ballasts had 50% failure. There was a chip problem. Fortunately, the manufacturer stepped up and paid for not only the replacement gear, but also the labor. But the fact is that most of the time, if there is a lighting controls failure today, it's a failure of design, not the hardware. Most of the time, the hardware works. Not always. There's always infant mortality. There's sometimes problems. But generally speaking, the hardware has gotten tremendously better, just like every other electronic component has gotten better, right? So think about that. Now, how do we keep all of this stuff straight? So I like matrices, right? We've got a lot of different ways to think about lighting controls here. I keep for myself a big matrix of different types of spaces that I've worked on in different types of strategies. So you'll notice at the top, there's all the different types of control strategies that I would typically use. And then, boutique retail, I might have manual dimming, I might have vacancy or daylight sensing, I might have preset scenes, I might have tunable white, I might have color changing, right? This kind of starts to help me to wrap my arms around how all of these things come together. And then when I'm, developing my basis to design narratives or documents or whatever, I include things like this. We'll see a little bit more of that as we move forward. So let's go to our next pop quiz. What are some of the key control strategies that we might employ? Let's go ahead and give you a minute to do that. Can you guys see it? There we go. Do 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 do. All right, going to give you another 10 seconds. Most of you have voted. Let's go ahead and close and share. Now, somebody mentioned check more than one box, and the answer is yes. You can't check more than one box in this particular thing. The key thing here, other than turning down the thermostat, these are all sort of key control strategies. Part of the reason that John, that I keep it as one is because I'm curious always who's going to select what. So daylight harvesting, of course, is a big one. Vacancy sensing is the one that everyone always kind of gravitates to. Why? Because it's ubiquitous. 13% task tuning. I want to call attention to this. One of the best ways that you can save energy on a project is task tuning, and it costs nothing. if you have a networked lighting control system, it's only making sure that you actually program it that way, right? So from a hardware standpoint, there is zero additional cost to a significant amount of savings. Please, 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 please remember this on projects, right? It's one of the best things you can do. All right, we're gonna zing through real quick here a little bit of dimming 101. Now, let's see, is my camera not on? Why did I lose myself? I'm gonna hope that people can still, oh, that's why, because I haven't hidden the poll yet. There we go. Okay, so a little bit about dimming 101. I just wanna talk about some of the technology, let's say, and I'm going to do this at a 10,000 foot view level. So any electrical engineers in the room don't sort of don't string me up, because I'm going to be glossing over a lot of detail here, right? So lighting controls sort of in the very beginning came from theater, right? And if you were seeing a Broadway show at the beginning of the electric age, you'd see these big tubes that were full of water and salt, saline solution, and they would have a cable going out the bottom and a cable going out the top with a plunger. And the closer you got two plates with the cables together, you know, basically a stagehand would plunge this thing in. Closer they got together, the brighter the lights, the further apart, the dimmer the lights. Hopefully those stagehands all had really excellent health insurance. If we skip over a bunch of generations of technology, we come into the 1950s, semiconductors really revolutionized dimming, right? The first wall box dimmer that did something other than bleed heat into the wall, right, with a resistor, was this triac controlled wall box that was put together by Joel and Ruth Spira in their apartment in Brooklyn, New York. And they went on, of course, to form a company called Lutron. Now, basically what these things did was they're essentially switching power supplies, right? So they switch the lights on and off a certain number of times per second at certain points within the electric, the sine wave of the electric power. And they modulate the amount of energy going to an incandescent lamp in that way. Now, this kind of control, either with triacs or what we call silicon controlled rectifiers, kind of kept going, right? In the 1980s, things like insulated gate bipolar transistors and field effect transistors, we're not going to get into the details here, gave a different way to do essentially the same thing. But either way, it's something we call phase cut dimming. So how does that work? So in the first case with the triacs or the silicon controlled rectifiers, right? So we have our sine wave, electrons moving forward, electrons moving back, right? That's how that works. So again, I'm wildly simplifying. The forward phase cut, the triac or SCR dimmers, will have the power off and it will turn the power on at a certain period in this cycle. This happens 120 times a second, right? For a 60 cycle system, 60 hertz system. So what will happen is power's off, power's on, right? Power's off, power's on. This would correspond to basically, let's say 60% light output on a dimming system. If we wanted 50%, we might come over a little bit more. This is also ignoring some other visual issues that we're going to talk about. The newer systems, the IGBTs and the field effect transistors, did something that we call reverse phase cut. So basically, they would start from zero and ramp the power on and then turn it off. Ramp the power on and then turn it off. Sometimes you hear this kind of technology called soft start, right? This kind of stuff, the forward phase cut, gets really damaging. That's not damaging. It's jarring, right? To, let's say, an incandescent filament. That's why you get the hum. The reverse phase cut is very gentle, right? It doesn't give you that 60 cycle hum. So forward phase cut, very inexpensive. That's why most home dimmers are sold this way still today. Now, if you've got a system that you're having problems with, you might be able to go to the reverse phase cut, right? That will go ahead and potentially take care of that. Now, another way to think about control is this idea of pulse width modulation. So those of you who are kind of calculus folks will sort of think about this as starting to break up the sine wave into, instead of just one part, we break each sine wave into many parts, and we switch the lights on and off very quickly, right? And from the perspective of, let's say, the oscilloscope we're about to look at, it starts to look like we're going ahead and instead of off, 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 on, it starts to make the sine wave appear like it's actually modulating up and down. And there's no better way to show you that than to show you that. So here's an example. So here's an oscilloscope. I've just turned it off. Now I'm turning on an incandescent source with a triac dimmer, and you'll notice that at the beginning we have off, off, on, right? See that? And then it slides down. I'm gonna turn that off. Oops, I'm gonna do it again. All right, next I'm gonna go to a reverse phase, and you'll notice that what it's doing is going from 0 to sliding on and then turning off. And again, that's much less jarring to the system. We don't have overshoot from 0 to some other spike. Now this is pulse width modulation, right? So you'll notice that as I'm dimming up and down, oops, let me get that out of the way. You'll notice that the sine wave appears to rise and fall, right? So these are three of the primary ways that we actually start to think about lighting controls. Now, a key distinction here, the dimming in this case is happening in this device, right? There's a wall box dimmer that has the electronics here. In this case, the dimming is happening in this device. In this case, the dimming is happening in the light fixture itself. This is a native LED light fixture where we've got a device here that's simply sending a signal to the driver in the LED to dim up, to dim down. This is a big distinction, right? And it's important to sort of recognize that, because most of the stuff that we're talking about is native LED. So if we were doing this class even 10 years ago, we'd be spending a lot of time talking about the dimming characteristics of all of these light sources. But the reality is, almost all of them really are legacy sources that just don't matter anymore. So what we're talking about is LEDs, right? So LEDs, great little devices, they're basically all dimmable. This slide is actually fairly old in my collection of lighting control slides, because things haven't changed that much. The technology has changed significantly, of course, but the poor to great color rendering, white light, color, all these things have basically stayed the same. So the architectural impacts here, key things from our perspective, more flexibility and control, we have back to dimming, and we have some potential confusion, right? So let's start from the idea that we can talk about LED light sources in two ways. We can talk about LED lamps, right? Basically screw-based or pin-based, however they are, lamps, in which the control gear, the electronics, are all living within the lamp itself. Now, those are going to be relatively simple electronics, and they may or may not be dimmable, and they may or may not flicker as they dim, they may or may not do all those things. But basically, these all work with the wall box dimmers that we were talking about, right? The forward or reverse control dimmers that are changing the circuit, changing the light in the circuit that's going to the light source itself. The more modern LED light fixtures, however, we could think of these as native LED, are essentially chips or arrays of chips that are within light fixtures. And those are being governed by drivers, right? So that think of the driver as the LED power supply. It's essentially a switching power supply. Think of it as the same as the old fluorescent dimming ballasts. Now the physics are wildly different between the what the dimming ballast was doing and what the LED driver is doing. But from a control standpoint, right, we've got some kind of power device that's taking a signal from a system or a wall box dimmer, but it's taking an electronic signal. It's not having the circuit modified, right, in any way. Now, there are two main flavors, right, constant current and constant voltage. Now, it's important to think about which is which, but I don't have the time, unfortunately, in this class to dig into this too deeply, but one or the other will allow you to do deep dimming or not, and one has the potential for more flicker or more not. Now, the key thing here is when you are designing a lighting control system that's going to have dimming, please ask your reps for samples and play with them. Try to see what's going to happen. How deeply can you dim that light source? Is that satisfactory? If you can only dim it to 20% light output, that's a lot of light. That may not be appropriate. You may need to look at something else. But even now, today, 20 plus years into LEDs and lighting, it's important for people to really test things, right? Now, a big part of the reason it's important to test is this notion of flicker, right? Now, all light sources flicker if they're fed by alternating current. Even incandescent will flicker if it's fed by alternating current. The key questions are, what is the frequency of the flicker? How quickly is it flickering? And what is the amplitude? How deeply is it flickering, right? So we can go ahead and look at a graph that looks like this, and we can start to see, just like we saw with fluorescent, if we increase the frequency of the flicker, it gets less noticeable till we can't see it, right? Till our brains can't perceive it. If we decrease the amplitude, right, the amount, the lower the modulation, the less we'll see it. So an incandescent we barely ever see because it's flickering 120 times a second because it's hitting that 0 point off 120 times a second. And the cool down doesn't happen enough that we particularly notice it most of the time. But with LEDs, you might notice it, right? So a couple of things that you can do to help yourself. Specifying or purchasing very high quality gear, you get what you pay for. The less expensive, very inexpensive kind of 2x2 panels that you throw up in the ceiling, they're going to have cheaper components. They're going to have more potential to flicker, right, than some others. So if that's going to be a concern for you, go ahead and test. I can't tell you how many times people have come to me and said, can you tell me if this is flickering? I pull out a meter, yes, it's flickering. What can we do? Well, you can replace it with a light fixture that's not going to flicker, right? That's basically all you can do. A couple of things you can do to test. Many of us in the industry used to carry around things that look an awful lot like this, right? They're a little top that we spin it and you can see stroboscopic effects in the way that the thing spins, right? You can also pull out a camera, right? A phone, put it into video mode, and if you cycle it back and forth and you see lines going across the video, we call that a mismatched refresh rate. That will tell you that you're able to see flicker within that space. So that's an unfortunate thing. All right, so I'm going to give you another quick pop quiz here. What is doing the actual dimming in most LED light systems? Is it an actual wall box dimmer? Is it a 0 to 10 volt driver? Is it an LED driver? Is it a clapper? Or is it magic? Give you just a couple seconds on that. All right, most of you have voted. I'm going to hit close and I'm going to share. I love the fact that 8% of you thought magic, because frankly, it feels like magic sometimes. Some systems do feel like magic. The actual real answer here, there is one correct answer here, and that's the LED driver. most of the time, the actual LED driver is what's doing the dimming. The driver is what's telling the LED chip to go up or down. The 0 to 10 volt signal or protocol is actually what's telling the driver to tell the LED, right? So how does that lead into what we're going to talk about next? We have dimming control protocols, right? A protocol is simply a way or a language, think of it that way, an etiquette, if you will, in order to tell the driver or the system to do something. Now, there are a number of different control protocols out there. 0 to 10 volt is by far, oh, wait, I'm sorry, you can't see what I'm doing. That was dumb. 0 to 10 volt is by far the most common protocol that's out there. What that basically means is between the control system and the load controller or the driver, there is essentially a 0 to 10 volt low voltage wire. And what's happening is the system is looking for the difference in potential. 0 might mean that the lights are off, 10 volts might mean that they're at full, or vice versa, depending on the particular system. Now, the reason that this is ubiquitous is because it's inexpensive, right? Now, this is an old standard. We used to use it for fluorescent, but it honestly was on its way out in favor of digital systems, but it came back with LED because it is relatively inexpensive. So great system, use it, but understand that it's imprecise. If you have a big bunch of light fixtures, they might not all be dimming at quite the exact same rate. Now, DMX512 is a system that has been around since the 1980s, stands for Digital Multiplex 512 Channels. Essentially, this was originally a theatrical standard. It actually allows for a tremendous amount of precision and potentially bidirectional communication, although that's not necessarily always the case. It has some limitations. You can have only 512 control zones on each what we call universe, but you can have as many universes as you want. The difference between 0 to 10 and DMX512, DMX512 is typically what we use when we need high precision, color changing, all those kinds of things. 0 to 10 is kind of the vanilla everything out there, right? DMX is also much more expensive and isn't really wireless the same way that we can do the others. Now, DALI, Digitally Addressable Lighting Interface, is an open source digital protocol in which each driver is its own unique address or its own unique control zone. This started in Europe, was very popular in Europe for fluorescent, didn't really get a big toehold in the US for fluorescent, but it's actually rapidly becoming accepted in the US for LED when we want to have high performance control, but also when we want to have color tuning. It is possible to do color tuning with 0 to 10. It's just very ineffective in a lot of ways. It's not really very precise. DALI offers a lot of precision. I wish we had more time to go into that in this particular case, but just understand that this is another one of those protocols out there. And there are proprietary protocols that we might find. Most of them, oddly enough, are based on some flavor of DALI with a bunch of other stuff added on top, right? So the protocol is how you talk between the system and the actual driver, right? Now, how do we communicate some of that stuff? How do we communicate that language? Most commonly today, we're really seeing that people are going to wireless systems, right? Most of the market, not just for lighting controls, by the way, but for a number of other building controls, wireless communication through a variety of different methods, Bluetooth, Zigbee, Enocean, Wi-Fi, becomes a very common way to do this, in part because it's so much less expensive upfront, and it's actually much less expensive to make changes over time. Right? So if we're assuming wireless communications, there are two dominant ways that we can do this. One is called a star and the other is called a mesh, right? So with the star configuration, you basically have some kind of communications hub or spoke here, right? And it's speaking to all the devices, the light fixtures, the sensors, the switches. It's essentially aggregating all the information and serving it out accordingly. Or you might have a mesh where each one of the devices kind of is a little bit more intelligent and they speak to each other so that they communicate sort of broadly. Now, the benefit to the star is that everything tends to be easily battery operated. The benefit to the mesh is that you can have extended ranges, but you typically have to have more of the equipment wired in order to provide power so that each one of those devices can basically re-radiate the signal. Now, there are a lot of communication sort of considerations that you need to have here, particularly with respect to your building materials. Is it a wood wall? Is it a metal stud wall? Is it a 2-foot thick concrete wall with rebar? But basically, it's the same kind of things that you would think about if you were laying out Wi-Fi. The good news is most manufacturers will go ahead and help you with determining how to lay these things out. Another big thing that you're going to wind up having here is the whole notion of cybersecurity, right? Everybody is concerned about cybersecurity, every building system. So we're not going to talk a lot about that right now, but assume that if you go to, we'll talk about this more next week, by the way, in the second part, some of the ways that you can think about how to protect your systems, how you can have cybersecurity, but understand that this is an issue. Now, the last thing that we'll talk about today is a little bit about the lighting control systems. Now, lighting control systems, right? We start to take all these little parts and pieces, aggregate the ideas, all these different things. There are a lot of different ways that we might think about this. In the old days, we would have things like low voltage relay systems, right? We would have a load center that would then either provide individual circuits into relays or provide a big power feed into a relay tub. And the relay tub would go ahead and serve out individual circuit control to our various zones. And then we might have programmable wall switches on some kind of programmable digital bus here. Now, we tend not to see this as much anymore today because this is a circuit-based control system, right? This requires a lot of copper, requires a lot of pre-thinking, and it also requires a lot of space in an electrical closet, because we all know that we have plenty of space in our electrical closets, right? So we want to be careful with this kind of stuff. Plus, it doesn't really allow dimming. Okay, well, if we're going to assume dimming, then we can move forward and add on a layer of dimming with a preset architectural dimming system, which is essentially like a relay system, except that it has either triac or silicon controlled rectifier or even reverse phase control dimmers, but the same things apply, right? You have lots of home run wires. You have a central tub within an electrical closet somewhere. So we tend not to see these as much anymore, except places like casinos, maybe things like that. The big thing are distributed systems, right? So in distributed systems, we have those load controllers that we were talking about, or we have smart drivers, and we wind up aggregating them along the same circuit, right? So the control zone is completely divorced from the power circuit. We can have all of these different control zones on the same circuit that's coming from our load center, and then we can communicate wired or wirelessly with those particular devices. It saves miles of pipe and wire, much easier to install, much easier to maintain, much easier to change over time. Now, the special case of that is, of course, DALI, right? So we have DALI, this digitally addressable lighting interface, where basically all of the lighting controls or light fixtures are their own control zone. Now, that leads directly into the notion of luminaire level lighting controls. So LLLC basically just means we take all of this capability and put it into one light fixture, right? So we have the sensors in the light fixture themselves. We have everything from the factory, the load controller, the software, all that stuff basically comes from the factory. You throw it up in the ceiling, program it, and it works, right? Tremendous advance for some of these things. These are not necessarily new, but the fact that they work well is relatively new. Now, the last one that we have is this whole notion of power over Ethernet, which is essentially a special case. It's getting very popular, actually. And the idea is that we wind up having a switching, supply, just like we would have for a computer network. And we're wiring to the light fixtures with home runs of Cat5, Cat6 cable. Now, the benefit here is that no electrician is required because it's low voltage wiring. The downside here is that no electrician is required because it's low voltage lighting. So there are pluses and minuses, right? You go back to the days of having centralized control, and you wind up having home runs. So there's a lot of wire to be done, but you have the ability to do a lot of data transfer if that's what you need. Now, regardless of which particular flavor we're actually looking at, the key thing is that these distributed control systems are better than they've ever been before, no matter what one you're talking about. And they are much more capable, much less costly. They're integrated, they're all better. So take it as written. We'll talk much more in depth about the parts and pieces of these network lighting control systems, how they come together, all that stuff next week. But I'm going to give you our final pop quiz for today. What is the most common dimming protocol in use today? And I'm going to launch that. DMX 512, 0 to 10 volt, Dolly, or is it Strunk and White? And I'm going to close and share. The most common protocol that we use today is actually 0 to 10 volt, although that's potentially changing with Dolly as we jump into that, as we really start to think about how we have some other issues going on. Now, I'm going to take the last couple minutes here, and I am going to give you a homework assignment. Sorry, I'm running a little bit slowly here. So I might run over just a minute or two. Let me hide this. There we go. All right. So I will have asked you earlier to download some stuff, right? So part of what you'll see is this Project X homework. I've given you plans, right? Plan for an open plan, private office, small conference room, medium conference room, a luminaire schedule, so what the actual light fixtures are, some things to think about, our specific target light levels and our initial light levels. This is a section. So I've given you some information, and what I would like you to do is to go ahead and spend some time this week thinking about how you might consider lighting controls for these offices. I've also given you, of course, the renderings here. How you might consider applying some of the concepts, the control zoning, the hardware, the parts and pieces that we've talked a little bit about, and how you might start to annotate some of that stuff. And then what I'd like you to do is consider, this is what we call a sequence of operations. Now, sequence of operations essentially is, what do you want this thing to do, right? What do you want each of these systems to do within that space? Think about that. Maybe try to take your hand at filling this out, what I mean by this, and think about how you would approach that for next week. What we'll wind up doing is going ahead and starting. I'm interested in how you guys would think about this sequence of operations, meaning what is supposed to happen, right? So we'll start off next week's class with talking about sequence of operations, how we would go about filling something like this out. Then I will spend a little bit of time talking to you about how I would look at the lighting controls for this space, both from a standard network lighting control system standpoint and from a luminaire level lighting control system standpoint. We can sort of compare, contrast them. And then we'll go through some of the very specific parts and pieces of most network lighting control systems, how to physically apply them onto a project, and then how to actually set them up and get them going. So I hope that's all makes sense for everybody for next week. With that, oh, it's actually 12 o'clock exactly. So apologies, I'm a few minutes behind where I normally would be. So let me give you just, I'm going to leave this up for other classes that we've got going on. And I'm going to ask, does anybody have any questions before we adjourn for the first part of network lighting controls fundamentals? I have tossed a whole bunch of information at you very quickly. Please feel free to email me again at there's my email address. If you have specific questions during the week about this as well, we'll go ahead and address them at the beginning of next week's class. Anybody have any questions? I'm not seeing any others. John, I promise you we will speak about Don Norman at the end of next week's class, by the way. There is a specific place, the design of everyday things, if anybody wants to take a look at it. Any other questions? Going once, going twice? I am not seeing, oops. All right, so then I will remind you, please go ahead and consider the homework. Please go ahead and fill out the reply for the class today. And if there are no other questions, I will go ahead and say thank you very much. Have yourself a lovely sunny Seattle afternoon, and I will see you all bright-tailed and bushy-eyed next Thursday, same bat time, same bat channel at 10 a.m. on Thursday, where we will do part 2. Fair enough? Thanks, everybody.